Here we go. We have a question subarray range with given sum. So you have given a unsorted array of integers and a target. We need to determine the number of subarrays whose elements sum up to equal to the target value. So we have this test case. In this test case, this subarray with sum minus 10 are first is this array. So if you sum up all the elements in this subarray, the answer will be minus 10, and another is this, which means minus 2, 2 minus 2, then minus 20 and 10. So its summation is also equal to the target value. Then the next subarray is this. So in total we have 3 subarrays. So the answer is 3. Let's talk about next example. In this example, only one subarray is there, which means this subarray whose summation is equal to the target value. So let's try to build the approach. So we have this test case. In this test case, we need to find the subarrays whose sum is equal to the target value. So first is this array. This is the subarray whose sum is equal to the target value. So let's say it is equal to target, and till here the sum is b. Let's say b, and the remaining subarray, which means this, the value, the sum value is a. So I can write this equation as b is equal to a plus target. We know b. So if we sum up all the values till here, if we sum up all the values till here, and we subtract our target value, so this is the left out value. So what I mean is, if I do b minus tar target, it is equal to the a, which means the left out value. So we need to check. We have the summation till the ith index. If I subtract my target from it, and the value, the left out value is a, if a value is present before that, which means there's a subarray whose sum value is equal to the target. So let's try to run the algorithm by using this formula. We have this formula. So this is important. Here b means all the values till here. So I can say the b variable to equal to sum. So let's change the b variable, and it is equal to sum. So we have this. So let's try to run the algorithm. First, our sum is 0. So let's start our sum. Here the sum is 0, and now the sum is 10. So we need to check 10, and the target is minus 5. 10 minus minus 5, which means 15. Is 15 there before that? No, 15 is not there. So we just moved ahead. How do we check if 15 is there? So for that we have a map. Map will store the value till here, the value till ith index, and the corresponding frequency. Why do we need frequency? Because we need to return the total subarrays count. So the value, the sum answer is 10, and frequency is 1 till here. Now let's move ahead. Next we have this. Till here our sum is 10. If I add this, the sum will be 6. Is 6 minus minus 5 is there in the map? No, it is not there. So we just move ahead. So first I need to add or insert this value, and with this corresponding frequency. Then our next value is this. So 6 minus 3 is 3. Well, sum is 3. Then we have minus 5. It is equal to 8. Is 8 there? No, it is not there. So let's move ahead. And before that, let's store the value with the corresponding frequency. Next we have 7. It is equal to 10. So 10 minus minus 5, 15. 15 is there? No, 15 is not there. So just store the sum value with the corresponding frequency. Next we have minus 1, the value will become 9. So 9 minus minus 5, it is equal to 14. 14 is there? No, 14 is not there. Actually 10 and 10 is there, so 10 frequency will increment. My mistake, I just forgot that. Next we have 9, so 9 is not there, and 9 minus 5, which is equal to 14, it is not there. So we need to increment the frequency of 9, the frequency will become 1. Next we have minus 3. If I subtract 3, the value will become 6. So 6 minus 5, it is there, which means 11. 11 is not there. So just push the 6 with the corresponding frequency. Next we have minus 1, 5. So this is the important case. So we need to check sum is 5, next target is 5, which is equal to 0. So what it means is, sorry, I just made a mistake. So 5 minus 5, it is equal to 10. So 10, and 10 is there. 10 is there. What it means is, there's a 10 two times. So first is here and first is here. What it means is, we have this and it is equal to the target value. And before that, the value, the summation is equal to 10. So let's say it is equal to A and this is equal to B, or this is equal to sum. So if I subtract sum, if I subtract target from sum, we get A. We are left with A. So we need to check, is A there? Yes, A is there, and its frequency is 10. First is this and another one is this. Let me change. So you can say, as you can see, first we have this. Its frequency, its summation is equal to, the target itself. Target is minus 5. So then we have this. Its summation is also equal to the target value. How? So let's check. This value is equal to 0. Then this value is equal to minus 5. So you can say this subarray is also equal to the target value. So we now just found two subarrays. So let's say our answer now it increments to 2 because 2 is there. Now let's move ahead. Before that we need to push 5. So let's push 5 with the frequency 1. So next we have 2. So 5 plus 2 is equal to 7. The value is 7. 7 minus 5 is equal to 12. Is 12 there? No, 12 is not there. So add 7 with this frequency 1. So I just noticed 6 is there and 6 is there. So we don't need 2 times. We just need to increment the frequency. So next we have 3. So it is equal to 10. So 10 minus 5, it is equal to 15. Is 15 there? No, 15 is not there. So just push 10 with value. The frequency will become 3. Next we have minus 3. So the value will become 7. So value will become 7. So 7 minus 5, it is equal to 12. Is 12 there? No, 12 is not there. So let's move ahead. Next we have this. The value will become 0. Means this value. So let me first erase this. This summation is 0. I think I just forgot 7 because 7 is 2 times. So we need to increment 7. I just missed that step. So next we have 0. So 0 minus 5 is equal to plus 5. Is 5 there? Yes, 5 is there. 5 is there with the frequency 1. Means this subarray, the value of this subarray is equal to minus 5. So we just found one more. So now we need to increment our answer. Answer is 3 now. So let me add one more value. Before that we need to first push 0 with this frequency 1. So let me add one more value here. So let me think about the value. So let's add minus 5 here. So minus 5. Then the summation is minus 5. So what I mean is minus 5 minus 5 is equal to 0. Is 0 there? No, 0 is not there. But the subarray summation is equal to minus 5, means it is equal to the target. It is equal to the target, and 0 is not there. So initially we need to do just one more step. We need to push 0 with this frequency minus with this frequency 1. So if I have 0 with the frequency 1, I think I have 0 already. Uh, but it's a subarray. The value of this subarray is minus 5 itself, and this value is also minus 5. So there are two subarrays to this index. So we need to add one more 0 initially, because to satisfy this condition. So that's how this algorithm will work. Let's try to code this. So first I have a map, then initially we need to push 0 with the frequency 1. Next we have current and answer. We have a for loop. Then we are summing, we are adding every value, and if the value is present in map, means current minus target is there, we pick the frequency as we pick 0. Then if current value is there in map, we need to increment the frequency. If value is not there, we just need to push the frequency of 1. So for that we have a merge function. It is very shortcut, you can say it's a shortcut. So we are just incrementing current, the frequency of current by 1. So just return the answer at the end. So let's give it a try, and let's talk about time and space complexity. In this code, the time complexity is order of n and space complexity is constant. Thank you all for watching. The code is given in the description box.